Okay, guys, so now to talk about a confidence interval that will compare two means. So you're going to see that this is basically taking the idea of a confidence interval of a single mean that we did in chapter 22, and then you're kind of combining the idea of what we just did in the first video. So um, where your standard deviation comes into play is probably what is going to look significantly different than a confidence interval for a single. Okay, so let's get started here. So your conditions, as always, have to be random, your 10%, your independent, and then again, your normal or large sample. So your distribution has to look normal or you have to have a large enough sample. So we use the general, that rule of thumb of 30. Big difference here is that because you have two samples, you're going to have to run your conditions for both of your groups or both of your samples. Okay, and so your confidence interval, we're going to use the following to be able to find it. Okay, so this is kind of where that first video came into play. So the difference between your two statistics is going to be your statistic. You're still using a t because you're dealing with means, so it's still a t distribution. And then here is what we are going to have to use for our standard deviation, which will be our standard error again because we don't know our standard deviation of our population, only for a sample. Okay, so I think it's best if we run through a quick example and be done with this, and then we'll take a look at more examples and do significance tests in class tomorrow. So the Wade Tract Preserve in Georgia is an old-growth forest of longleaf pines that has survived in a relatively undisturbed state for hundreds of years. One question of interest to foresters who study the area is, how do the sizes of longleaf pine trees in the northern and southern halves of the forest compare? To find out, researchers took random samples of 30 trees from each half and measured the diameter at breast height in centimeters. Comparative box plots of the data and summary statistics from Minitab are shown below. Construct and interpret a 90% confidence interval for the difference in the mean DBH for longleaf pines in the northern and southern halves of the Wade Tract Preserve. And then it says much of the same thing. Okay, so first thing that I'm going to want to do is kind of set up what I'm going to call my first and my second sample. Okay, so I'll call my southern part U1 and my first sample, and then I'll use 2 for my northern. Okay, I am kind of doing this on purpose, so I am doing that to be able to subtract a higher number from a lower number just to avoid that negative there. Okay. So those are our parameters. Okay, so the first thing I should do here is always state my parameter, and then the next thing I'm going to start to do is check my conditions. So it's random. They say the data come from random samples of 30 trees in both of the northern and southern paths. It is normal because that box plot showed, it would appear to be maybe slightly skewed, but it's certainly not a strong skew, and you definitely do not have any outliers here. So it's safe to use a t distribution here. Okay. The other idea is the other idea is that it is a sample size of 30. So actually you were safe even if you didn't have the box plots because they did have a large enough sample. So kind of more than you even needed here. And then independent, so I think it's safe to assume that 30 trees would be within 10% of trees within a half of a forest. Okay. So we are obviously going to use our degrees of freedom. If we're using a t interval here, that means we need a t distribution. So at some point we're going to need our degrees of freedom. That's going to come from finding your t critical value. Okay, so we will use degrees of freedom of 29 here. So the question will come up next class, what happens if we have different sample sizes for our groups, and we'll talk about what we will do then. Okay, so So in general, this is what it is going to look like. So here's your, what we called your southern half was the first one minus your second one. Here's your t critical value. That's found from your inverse norm. You did a 90% confidence interval, I believe. Right, so half of the 10. And degrees of freedom was 29, okay? This is going to give you a negative unless you use the, unless you do 1 minus it to get the positive. But other than that, you could just ignore the negative. Degrees of freedom is n minus 1, okay? Your standard deviations were given to you, plugging in. You get as follows for your confidence interval. Okay, last step in a confidence interval is always to interpret. I'm going to erase this so we can see that. Okay, so we are 90% confident that the interval between 3.83 to 17.83 centimeters captures the difference in the actual mean DBH of the southern trees and the actual mean DBH of the northern trees. This interval suggests that the mean diameter of the southern trees is between 3.83 and 17.83 centimeters larger than the mean diameter of the northern trees. And that's it for the first video. We will talk about how to put it into the calculator, and we will talk more about significance tests in class. See you guys then.